Thank you very much. It's great to see all of you here. Now you've heard a lot that's talked up what I'm going to be doing, so now I'm all worried about whether you're going to be all disappointed. I don't think if anyone has come here to tell me I'm totally wrong, but please go ahead. I mean, this is the conversation that democracy lives off of. I'm hoping to give you some of the arguments that at least can tell you why I think there is an other side that you might want to hear if we're going to have a good conversation about how we deal with global warming and climate change. So I'm going to take you through a PowerPoint. That's partly because all I do is about cost and benefits. It's about data, and so I have to show you all of this on the slide. I usually walk around, but they'd like me to sit still. So if you see me fidget, you also know why that's the case. So first of all, and as Teresa also said, so thank you very much, both Teresa and Alejo. Thank you for your gracious introductions. Global warming is real. It's man-made. It has a significant and negative impact in the long run. So let's just get that out of the way. This is not a conversation about, oh, is it really happening or something. This is not Trump fodder, right? This is a true and real problem, but I think one that we're very, very bad at tackling. So it's also important, and that was what Alejo's point was, that you need to have a sense of what's the impact. Well, what's the impact right now? If you measure all the costs and all the benefits from global warming, and now to a lot of you, it'll be like, really, there are benefits to global warming? But of course there are. Yeah, any problem will both have cost and benefits. One obvious thing is as temperatures rise, you'll have to have more cooling costs, but you'll have less heating cost. Very simple. If you do these models, basically it turns out the cost right about now is about 0% of GDP. Very surprising. And by the 2070s, and this is again the conclusion of the UN Climate Panel, the IPCC, the cost of global warming will be somewhere between 0.2 and 2% of GDP. That's a problem. It's not the end of the world. Now, you think, why the hell haven't I heard about that? Well, actually, this is the update of the latest IPCC report. This is their estimate of all the impacts. So if you look out at the x-axis, you can see the temperature. So the higher the temperature, the bigger the problem. And then you can see what's the problem in relationship to GDP. So you see it in percent, and these are all the studies that are out there. This is the updated version by Nordhaus, the guy who just won the Nobel Prize in climate economics, the first economist to win the Nobel Prize in climate economics. I'll get back to him later. So this is based on the IPCC's work, so the UN Climate Panel's work. And again, most of what I'm going to show you will be somewhat surprising because you probably haven't heard it, but it's absolutely well sourced. It's not, something I made up in the shed, and it's not something that just a few people say. This is absolutely true. So global warming is a problem, not the end of the world. How's that possible? Well, one of the problems with global warming is that it's dramatically exaggerated in much of the conversation. That matters because if we constantly hear, oh my God, this is the end of the world, we're likely to believe it. I don't know if you remember back in the 90s, this was a problem in many parts of the world. We saw a dramatic decline in crime. Yet pretty much everybody believed that crime was getting worse and worse. All the old ladies were worried that they were going to get mugged, that crime was just rampant. And that was, of course, one of the reasons why a lot of parties could win on being very tough on crime. The problem was that at one hand, you had the statistics that told you, no, actually, we have less and less crime. On the other hand, you had a lot of media who needs to sell stuff that's interesting. One of the interesting stuff is, oh, this poor lady just got mugged. It's a great story to tell, but it doesn't inform you very well. So we don't want to end up in a situation where we get one point of view from the media, namely things are getting worse and worse, when it actually is getting better and better. That was the problem back in the 1990s, and I'm going to make the argument that that is true in very many ways in global warming. Of course, I'm not going to convince you by just saying that. Let me just show you this. And again, this Al Gore is always a good reference. Right? He'll tell you, it's like a nature hike through the book of Revelations on the news every day now. And that's pretty true. I mean, we see one catastrophe after the other, and we're told this is what we reap from keep putting out CO2. Obama likewise tell us we're going to see more extreme droughts, floods, wildfires, hurricanes. Perhaps not surprisingly, I don't have a quote from Trump. So let's just look at some of these things. And again, I want to conserve time, so I'm only going to look at some of these instances. I'd be happy to take that up afterwards, but I think you'll find that there's a lot of other things you also want to talk about. So let's just take a look at droughts, floods, and hurricanes. I'm not going to look at wildfires, but we can also talk about that. So droughts. What do we know about drought? Certainly, we get the sense that, oh my God, there's more and more drought. Actually, if you look, this is from Nature, one of the latest studies, on all major indicators of drought, we've seen a decline in drought over the last, 30 years. 30 years, right? Not what you hear, but it just happens to be what is actually the case. Again, if you look at what the the U.S. Climate Change Science Program, so the one that very clearly tries to challenge President Trump, they say droughts have, for the most part, become shorter, less frequent, and cover a smaller portion of the U.S. over the last century. Again, what? I keep hearing the opposite on the news. And remember, it is entirely true, likely entirely true what you see on the news. Here's a drought, here's a drought, here's a drought. But that does not add up to more drought than what we used to have. And we'll get back to that. That's just not a good argument. When we see individual instances, they're probably true, but what you need to ask is this overall worse or better than it used to be? The UN Climate Panel, the IPCC, which I'll be quoting a lot, likewise says there's overall low confidence in a global scale observed trend in drought. These are things that we should know, but we don't know because we're just way too scared of saying, of course there's drought, and of course it's caused by global warming. Now, the future will bring more drought. So the future from the UN Climate Panel tells us there's medium confidence the drought will intensify in some seasons and areas, overall low confidence elsewhere. So global warming will cause more drought in the future. Yes, there is a problem. This is why it is an issue that we should be concerned about. This is why it will have a net cost. But it is not what we're seeing right now. And again, we need to come back and I'll show you that, why it is that it's so much less of an impact than what you'd often think. Let me take you to some of the other things. Floods, we've just had this flood in Southern Africa. And of course, this gets played up every time we have a flood. We have the best data for the US, which is why I'll often show you the data for the US. But if we look at the world, the UN Climate Panel again tells us that there continues to be a lack of evidence and thus low confidence regarding the sign of trend in the magnitude and or frequency of floods on a global scale over the instrumental record. We don't even know if floods have become more or less frequent. The UN Climate Panel doesn't even know whether it's a plus or a minus sign, whether it's getting worse or getting better. Let's just take a look at and this is the cost of US flooding. Where we have by far the best data. We also have similar data, for instance, for China from 1990, so only 27 years, shows the same impact. If you look at the cost of US flooding, that has gone up. But that's not very surprising. We would see that with pretty much everything. If you have two expensive houses to be flooded rather than one cheap shed 100 years ago, then obviously the cost will go up. The question is, has the relative cost gone up? One good way of regulating that, it's not the only one, but it's one that a lot of the literature uses. One good way of doing that is to compare this to GDP. So basically say, are we losing an ever bigger share or a smaller share of our values to flooding? And here's the cost of US flooding from 1903. You can see the huge flood in 1912. And basically, what you see is a dramatic decline over the last century and up till today, up till 2017. The new 2018 numbers will be published in a month. This is a substantial evidence that we see pretty much everywhere. We see it for China, we see it for France, we've seen it pretty much everywhere, that we have lower and lower costs from flooding. Very contrary to what you believe. This is not the same thing as saying that global warming can't actually be slightly increasing this. because most of this has nothing to do with flooding. This is to do with technology, with our ability to tackle problems like flooding and like drought and other things. This is basically an indicator of us getting wealthier or getting less vulnerable. And that's a great impact, but it goes very contrary to what we mostly hear on, for instance, flooding. Likewise, in hurricanes, I'm just going to do this very quickly. The UN Climate Panel tells us globally there's low confidence in attribution of changes in tropical cyclone activity, that's what they call hurricanes, to human influence. There's just a recent paper that came out, I believe, 2 weeks ago that again pointed out what we know, that we don't really believe that we'll be able to tell you whether there's more and stronger hurricanes before mid-century because of global warming. Very contrary to what you hear. You constantly hear, oh, this hurricane is certainly consistent with, which is slightly weasel words, consistent with global warming. That's true. Everything is pretty much consistent with global warming. The question is this actually what is causing the problem? And as of right now, we cannot say. For the future, again, just like I pointed out with drought, we expect that we'll probably see a decrease in the number of hurricanes, but we'll see an increase in the ferocity of these hurricanes because of global warming. Overall, that will translate into worse outcomes because, yes, it's nice that there are fewer hurricanes, but each one of those will be stronger and that will be a problem. Overall, that will cause more problems for humans. Again, that's one of the reasons why global warming is a real problem and something that we need to tackle. But again, let's get a sense of proportion. How big of a problem is hurricanes? Well, we actually know. This is from a Nature study back in 2012, and still, I think, the best one that actually looks at the relative impact. Right now, hurricanes cause total global damage of 0.04% of global GDP per year on average. That gives you a sense of the proportion of the damage that we're going to get. If there was no global warming, by the end of the century, this study estimates we would see about 0.01% of global GDP being lost to hurricanes. Why? Because getting richer means that we're much better able to adapt ourselves. Fundamentally, if a hurricane hits Florida, yeah, a lot of stuff gets broken, but very few people die, and Florida very quickly gets back up. If a hurricane hits Guatemala, it eradicates their economy. We saw that with Hurricane Mitch, for instance. It eradicates about a third of their economy for years on end. It kills thousands, possibly tens of thousands of people. It has a huge impact. So getting richer or getting out of poverty is a great way to have lower vulnerability. Now, because global warming will make hurricanes more ferocious, probably fewer, but more ferocious, we estimate that with global warming, we're likely to see 0.02% GDP loss every year because of hurricanes. Now, notice what is true. It's both true that global warming will make hurricanes twice as damaging by the end of the century. But it's also true that with global warming, we'll actually see hurricanes only have half the impact by the end of the century as it has today. So it's a problem, but it's a diminishing problem, not an increasing problem. And this is true for very many of the things that we're talking about with global warming. It is a problem in the sense that it reduces the betterment of humanity. It makes it slightly less better by the end of the century. That's a lot different from what you hear from a lot of the arguments that this is the end of the world. It's not the end of the world. It's a slightly less good outcome by the end of the century. So yes, we will lose a frightening 0.02% of GDP because of hurricanes by the end of the century if we don't do anything about global warming, rather than only losing 0.01. That's a problem. It's not the end of the world. Just to show you, actually, and again, we have by far the best studies for U.S. Hurricane landfall over the past 117 years. There's actually been a decline in the number of landfalling hurricanes, and there's also been a decline in the strong landfalling hurricanes. Again, this is simply and we don't expect this to last. This is in some way an estimate of we've just been lucky. As you can see, there's that huge drought of hurricanes from 2006 to 2016, which was very, very fortunate for the US, but doesn't mean that that will happen in the future. But again, it goes against what we typically hear. My point here is simply to say, when you hear Obama and everybody else telling you there's going to be more drought, more flooding, and more hurricanes, you're not being well informed. Yes, there is not more until now. There probably will be more problems of some of these things, for instance, drought and probably also hurricanes, but they're fairly minuscule. And so this is the question that I first want to leave you with. Why do we get it so wrong on adaptation? And I think one of the things is we miss that people adapt, that we're actually really, really good at handling stuff. So let me just show you a few things. Let me show you, this is the database on disasters. This is the best database actually here from Belgium. For how many people have died from different causes of all kinds of causes, both climate and a lot of other things. Just give me a sense of what do you think will happen as we go across the century? Are there more and more deaths from climate or fewer and fewer? Most people will tend to say, of course, there are more and more. We see that all the time. I mean, look, over the same period from the 1920s till today, we've quadrupled global population. So it would stand to reason, of course, there are going to be more people dying from climate. Not so. This is the actual number of people dying every year on average from climate-related deaths. That is floods, droughts, storms, wildfire, and extreme temperatures. This is not a small change. Notice that we've gone from, in the 1920s on average, we saw about 500,000 people die every year because of these climate-related disasters. Today, it's down to about 20,000. We've seen a decline of 95% deaths from climate-related deaths over the last 100 years. And if we take into account the fact that we quadrupled, the risk has actually declined by 99%. Now, this has very little to do with climate. This has everything to do with the fact that we have come out of poverty. Again, we were all Guatemala back in 1920s. That's not entirely true, but you get the idea. We're not any longer. And of course, one of the goals that we should have is to make sure that Guatemala is not Guatemala in 2100 either, but that they're rich Guatemalans, that they're rich Dutch people, rich everyone else people. Likewise, if you take a look at flooding, one of the problems with flooding is that we're very often asked to entertain the idea that what will happen if sea levels rise? And right, sea levels will rise. It's one of the very, very clear and undisputed impacts of climate change. Sea levels will rise because of global warming, mostly because as water gets hotter, it'll expand just like everything else. And so we're likely to see somewhere between about 30 centimeters to a meter of sea level rise by the end of the century. What will happen? Well, let's just take a look. And again, this is one of the few articles that actually look at adaptation, so that's why I'm using this, but with all the respected people. So what they find is that right now, every year, about 3 million people are flooded. This does not mean that they all die, but that they're terribly inconvenienced. Typically that they lose a lot of their stuff and they probably have to move from their homes for weeks on end. This has a cost of about $14 billion in present day numbers, and this will, I'll always show you inflation adjusted numbers. This is equivalent to about 0.016% of GDP. So it's a problem. What will happen if the world doesn't do anything about global warming? We just keep emitting more and more CO2. We see dramatic temperature rises. We're also pretty poor, and we actually are lots and lots of people. So the worst case scenario, worst case warming, highest population, lowest GDP. What will happen by 2100? Here is what will happen. And this is the story that you typically see. If we don't do any extra adaptation, we're going to see 329 million people flooded. We're going to see cost every year of $17 trillion in cost. And we're going to see a cost of almost 5% of GDP. This is the standard story that you're being told. It's a very simple story to say, look, we look at the world, we look at the ISO charts of the maps, we rise, the sea level is almost 1 meter of sea level rise, and then of course everybody who's below that are basically flooded every year. It's a little bit like assuming that you stand on the seashore and you keep standing there as sea level rises for the next 80 years. It doesn't happen, but of course it's very easy to do in a model. But what will actually happen as we're also getting richer, because even in this poor world and in this very populous world, we'll be much richer, and I'll show you that, some of that later on. What will happen actually if you introduce adaptation? This will happen. This is the correct curve with adaptation, the blue one. It actually ends up with 1 million people being flooded every year, not 3 million as it is today. So despite that we're many more people, we'll have fewer people flooded. We'll have $37 billion of cost. So notice the cost has gone up, but we're also much richer, so it's actually lower part of GDP. But we also have to pay for more adaptation. I've written it down as DIKE cost, but there's a lot of other things I'll go into this, about $40 billion. So the cost will go up a little bit. But notice how trivially small these costs are. We're talking about 0.01, and now if you add the 40 billion, it's about 0.02. So the cost will be a little higher. We'll actually have a world where even if we don't do anything, we'll be better off. We'll have 1 million people getting flooded rather than 3 million, even though we'll be about twice as many people. The point here is not to say that there's no problem, but it is to say that we're being badly misled if we just hear the red line. But of course, the red line is the fun line to write. It's also the easy line to write. It's the one that's very easy to put into the newspaper, but it doesn't give us good information. If I can just show you, this is the last one, and this perhaps just summarizes this. This is the updated version. That's why it's a blog post. It's the updated version of the period published study from 2018, but that only had till 2017. The global cost of climate change as estimated by Munich Re, one of the big reinsurers. This is not the insured cost. This is what they estimate is the total cost of impacts from global weather losses over the past, 28 years. We don't have a longer one for the globe. We would love to have that, but we don't have that. And surprisingly, again, it's going down, not up. Again, this emphasizes that while you can certainly see a lot of individual problems, a lot of individual tragedies, and these are all true, you cannot make good judgment on just looking at individual actions. They do not add up because we forget that in the past, it was actually worse. So my point here is simply to say, you've heard a lot about how things are with global warming, and much of it is probably misinformed. And there's a reason for it because we don't take adaptation into account. But I promised to talk to you about, so how do we fix this? And the European Parliament heard from Greta Thunberg, and a lot of people have heard from her and from many, many others who say, and this is a very obvious thing, look, if global warming is such a big problem, and if CO2 is causing that, CO2 comes from us burning fossil fuels, why the hell don't we just get rid of that fossil fuel stuff? It's a very obvious thing. If the problem is CO2, stop the stuff that emits CO2. But of course, the point here is to remember that we don't burn fossil fuels to annoy the environmentalists, right? We don't burn fossil fuels to annoy Al Gore. We burn fossil fuels because it basically powers everything we like about civilization. It's what keeps this room warm, which I'm really, really pleased about, but also enabled me to travel down here, enables you to feed your kids, enable you to do pretty much everything we like about civilization. And so the point I want to emphasize is that we have this idea, and we've been told for a long time, oh, we can just switch to renewables. No, we cannot. And let me show you this. So this is the International Energy Agency, their latest report, and the latest global data is from 2017. This is how much solar energy we got. The world got, and remember, energy, not just electricity, because we need to decarbonize the entire energy structure, not just our electricity. Solar PV, they estimate, provided 0.27% of global energy. Wind provided 0.62%, and the rest, a little more than 99%, was not provided by solar and wind. We have this fancy that solar and wind is going to take over. No, it is not. If you take a look again at 2017, this is where we get our energy from. And if you look at where do we actually get zero carbon energy, that's mostly biomass. Biomass is hugely problematic. I'd love to talk about that, but I'm not going to get very much into it. For the poor world, this is mostly poor people burning wood inside their huts and leading to the world's biggest environmental problem, which is indoor air pollution. That's a terrible thing. For rich countries, it's countries like, regions like the EU burning American forests in European boilers and feeling very virtuous about it. But certainly it's not CO2 neutral now. It may be with some very, very strong assumptions in 100 years. Wind and solar PV, as you can see, provides very, very little. This is the IEA's estimate for 2040. As you can see, wind is going up and solar is going up. Wind and solar together will do almost a little more than 4% by 2040. But everything goes up, and that's of course the point here, to remember that we will need a lot more energy, and that's why it's going to be very, very hard to decarbonize. Let me just show you global renewables for the last 200 years and the next 100. So in 1800, almost everything we got was from renewables. In 1800, the world probably got 94% of its energy from renewables. This was mostly wood. The next 170 years, we spent getting off renewables, because renewables in many ways are terrible. They're hard to predict, they're energy poor, and they're certainly not something that you'd want in a modern economy. So that's why we didn't want windmills, or there wasn't solar panels, but sails on ships and so on. For the next 50 years, from 1970 until today, we've basically been stuck at 13 to 14%. We have not seen, as many would probably think, a dramatic increase in global renewables over the past 50 years. Actually, today, we're still at 14%. But what will happen in the future? Well, there's a couple of prognoses. The International Energy Agency estimates that if everybody does what everyone has promised in Paris, we'll probably get up to about 20%. More realistically, we'll get up to 16.5% by 2040. The UN Climate Panel has 5 major scenarios that they look at for what will happen in the world for the rest of the century. These are the 5 scenarios. And they also tell a very different story. Actually, 4 of the 5 scenarios will see virtually no increase in renewables. One, the absolutely greenest, sustainable scenario, will even by the end of the century get just 45% of its energy from renewables. So just notice, if we just zoom in on the 1950-2050, what will likely happen is that 1950 will probably still be the year where we got the most renewables in percentage terms, also out by 2050. This is very contrary to what we hear, but this is, if you will, a ball of cold water on our ideas of, oh, we're all running towards a green revolution very quickly. No, we're not. This is what renewables looks like over the past, over 300 years. Very likely, we're just getting off renewables. If we're very, very lucky, and I'll question that later, we could get up to 45%. This gives us a very different sense of what is possible and what should we be doing. This is mainly because global climate policies haven't worked. Remember, we promised back in Rio to cut our carbon emissions, and we didn't. We promised in Kyoto, and we mostly didn't. We promised in Paris, we're failing badly on those promises. Remember, since climate policies began in 1992 with the Rio Treaty, we've actually emitted just as much CO2 as we had up till that point. So it's not like we're really doing well. We're actually just accelerating. And again, this is simply because there's 2 very different perspectives. One is, oh, we should do something about global warming. The other thing is about most of humanity that would like to get out of poverty. A different way of looking at this is, we know that as technology improves, we get better and better at producing worth with less and less CO2. This is part of being more efficient. This also happens for energy. As you can see, it's declined dramatically from the 1960s until 1992. And then I'm also showing you what happened since then. Since we started having our climate policies, we've actually seen a decline or less reduction per dollar of CO2, dollar produced. So we've seen a slower decrease. Why is that? Well, this has very little to do with climate policies. This is mostly due to nuclear power in the first part of this, and China basically getting its development underway in the later part of 1990 and onwards, mostly powered by coal. But again, it tells you a very different story than the one that we like to say, oh, we're well ahead and we're going green. No, we're not. If you look at what is the CO2 emissions per kilowatt hour, and again, this is per energy. I've just converted it into kilowatt hours because it's a convenient way of looking at the world, but this is for all energy. Again, we actually saw a decline up till we started climate policies, and then we've seen a dramatic increase. Again, notice that the scale does not go down to zero. We're basically pretty much on the same level, and there's no way we're getting down to close to zero anytime soon. Paris also will have a tiny impact, even if we did what we promised. This is one of the things I think most people just haven't heard. And I'm surprised, but also a little, I know probably why this is the case. I did a period published article on this topic. So let me just show you on the one hand side. So on the left hand side, I'm going to show you emissions from 2000 until 2100. We, of course, have the historical emissions. We know what those were. And these are all in CO2 equivalent. So it also includes all the greenhouse gases that are not CO2 as a standard. This is sort of a standard business as usual. This is one the UNEP, so the UN Environmental Protection Agency, uses. This is also what Nordhaus, which I'm going to get back to, the Nobel laureate, uses. This is also what the Stanford Energy Modeling Forum has used, and many others. I mean, they're roughly the same. This is a business as usual. Now, let me put that into a climate model. And I'm going to use MAGIC, which is the standard model. It's been used by all the UN Climate Panel reports all the way back from 1990 and until the latest one. It was co-funded by the EU and the US EPA, so it's absolutely unproblematic. If you put this into MAGIC, it'll tell you what the temperature increase is. And in this case, it'll tell you we'll probably see a temperature increase of 3.8 degrees by the end of the century. This is totally uncontroversial. Obviously, with different assumptions and different models, you can get different outcomes, but I'm not really interested in that. I'm interested in showing you the difference, and this is very, very robust across models for that. So now we have a baseline. Let's take a look at what has Paris actually promised. Well, surprisingly, the UNFCCC, the climate framework that organized Paris, they put out a report where they said the total impact of all the promises that all the actors at Paris have made is the following. It's 56 gigatons of CO2. Now, for most people, that has no meaning. That's simply the area of the triangle that you're seeing there. That's the 56. This is if everyone does everything, also including all of their voluntary promises and all of their conditional promises. So this is the absolute best you can hope for the Paris. Now, take that and run that through the same MAGIC model, and you get this output. I'm not sure you can see that. Oh, now it is. There, it's the black line. You can't tell the difference, and that's, of course, why I did it, right? The Paris Agreement, it's 56 gigatons of CO2 will have absolutely no measurable impact by the end of the century. It'll have an impact of 0.04 degrees centigrade by the end of the century. This is not a matter of opinion. This is simply what the models will tell you. Now, if you plug it into a very friendly model, maybe you can get 0.05. And if it's an unfriendly model, maybe you only get 0.03. But we're talking about those kinds of impacts. Now, you could argue that Paris will also be continued. Now, remember, all the promises in Paris are only till 2030. But you could argue that all nations are going to stick to all of their maximal promises for the rest of the century. Remember, this is an incredibly strong assumption, but let's just make that assumption. That is basically that we will see this reduction all the way through the 21st century. That is not 56 gigatons, that's actually 540 gigatons of CO2 cut throughout the century. This is a very extreme assumption, but you could argue that. If you run that through the model, you see the slightly smaller temperature, the slightly bigger temperature reduction. You'll now see a temperature reduction of 0.18 degrees centigrade by the end of the century. So it'll probably not be measurable by the end of the century, but it's, we theoretically would probably be able to say that it's there. It's a noticeable, but certainly not a very big one. This is not what you heard from the climate summit in Paris and what you've heard since, because what you have heard, and this is what got printed in pretty much all reports, was this reduction. This is the Global Climate Action Tracker. This is one of the academic networks. And what they basically, I can go into more detail on this, but this is what they believe was the actual outcome of Paris. This is about 3,000 gigatons of CO2. Now, if you take a look at what the Paris Agreement by the UNFCCC of the 56 gigatons, the little black triangle, and then look at the Climate Action Tracker, you can probably make up a story to say that this was what will follow if everybody does what they promised in Paris. But it's very clear that this is not mostly what was promised in Paris. This is mostly what we would hope come after Paris. Of course, they're actually way ahead. Even in Paris, they're much more optimistic than Paris itself. But then afterwards, they say, oh, and then we're just going to cut like crazy, like gangbusters. But I dare you to say that that's a good way of telling us this is what will be the impact of Paris. If you run it in the climate model, you will see a dramatic reduction of 1.1 degree, which is also what you have heard all around the conversation. And now, if you just look at the 2-degree target, this is the UNEP, but there's many others, pretty much similar, about 6,000 gigatons of CO2, and that will run to, not surprisingly, below 2 degrees centigrade. And there you are. What is important to take away from this, of course, is to remember that the total promise of Paris, if everyone does everything they promised, is about 1% of what is needed to get to 2 degrees. We promised 56 gigatons of CO2. To get to 2 degrees, we need to cut about 6,000 gigatons. We are not anywhere close to doing what we're supposed to do. So we're happily promising 2 degrees because nobody really knows what the math is involved in actually getting there, but we're not actually delivering on that promise. And also remember, this is one paper from Nature. There's also another paper that came out from LSE a couple of months ago that showed basically nobody's living up to their promises. All major industrialized countries are failing to meet their pledges. So fundamentally, we promised something that we've been told is going to fix global warming, but in actual fact, we'll do almost nothing to do it, and we're not living up to it. Moreover, and this is not unimportant, as you also pointed out, Alejo, one of the points I try to say is, well, what will this cost? I am astounded, quite frankly, and I've talked to some of the people who are doing this, I'm astounded that no one in the world has done a cost of what will it cost to do the Paris Agreement. I mean, wouldn't that be sort of a reasonable thing to have before politicians go in and actually make a decision, should we do this or not? There is a big, I just want to show you, we have costly subsidies. This is, again, the IEA. This is the subsidies that we're paying for wind, onshore, offshore, bioenergy, solar, and other. So right now we pay about $150 billion by the 2040, which is when they end their investigation. We'll be paying almost $300 billion. If you add all of this up from today, we're going to be paying in the order of $6 trillion in subsidies. This is real costs. One way of looking at it, this is just if you correlate growth per year versus CO2 growth per year. And not surprisingly, there's a very strong correlation. If you get richer, you very often will emit more CO2. Now notice, you can actually emit less CO2, but you're also much more likely to have a low growth rate. So it's not the same thing as saying that you can not reduce your CO2 emissions and still grow, but you will grow slower. This is what all economic models show, and this is what I'll be showing you here in a short while. So the basic intuition here is simply to say, if you're going to force people to substitute cheap energy for slightly less cheap energy, it will reduce your output. It will not lead you to the poorhouse. It may still mean that you will grow, but you will grow less fast than you would otherwise have done. So let me just show you, this is my estimate of the economic cost of Paris. I was asked by the US Congress to make an estimate. This is made on the best public period studies on the cost for individual countries and regions. But it's by no means, and so I talked to, so most of the benefit, the cost estimates come from the Stanford Energy Modeling Forum, which is typically considered the gold standard for energy modeling forum in the world. They take models about 12 to 15 across the world and try to make similar assumptions to see what is the variance in all the different models. I talked to the guy who runs this a couple of months ago and asked him, why aren't you doing this for Paris? And he was like, well, nobody's willing to fund it. And I understand why, because nobody wants to hear this. But let me just take you through this. So using the best energy models from Stanford, I'm also using the Asia modeling exercise and the climático LAMP, which was EU funded for Latin America. Again, the costs are typically in loss of GDP growth, so that you see instead of a 3% GDP growth, you'll see 2.9% GDP growth. This is not very much, but over a century, it actually adds up. So if you'll just allow me, I'm just going to give you the very short version. If you use the most effective policy, which will typically be a carbon tax, for the US, we estimate if the US actually did their Paris promises, which was the Obama promise of 26, 28% below 2005 by 2025, I believe, that would be doable for $154 billion a year by 2030. For the EU, because you promised more and you're already more efficient, the cost will probably be about $300 billion. Again, this comes from different, these are probably made in euros, and then I've translated them into dollars to make them all comparable. Take them as a rough estimate. You'd have to actually do this better again if you want a complete and precise number, but about $300 billion. For China, this is by far the biggest uncertainty because nobody really knows, is China going to just go off on much more CO2, or are they actually going to turn around? I've used the Asia modeling exercise, which assumes that they will see an increase in CO2 emissions, which is why it's going to be costly for them to live up to their promises, which is mostly the binding promise. Actually, they didn't promise anything for 2030, but they did promise to get better at producing per dollar, and that's why you see the $200 billion. Mexico at $80 billion is, again, the EU funded study. And then the rest of the world, I've just simply scaled up to have the same. There's about 15% that is unaccounted for. And that's it's probably about 20%. And that's the rest of the cost. That adds up in total to about $924 billion. Now, we also know that no country has ever done the efficient policy, the one that the economists will tell you, one CO2 tax across all areas, across all barriers, across all time frames. The OECD famously have about 3,000 different carbon tax costs. Many of them are at zero. So we clearly are not able to do that. We have an estimate for the EU climate policy where we can show, period published, we can show that the actual cost was probably a little bit more than twice the predicted cost if it had been done in the most effective way. So it's reasonable to assume that at least in realistic outcomes, these guys will do something that's about twice as costly. I've just simply doubled all those costs, and then you get a cost close to $2 trillion. So a reasonable estimate of the cost of Paris Agreement is somewhere between $1 and $2 trillion a year. Now, this is not going to bring us to the poorhouse. This is 1 to 2% of global GDP. So it's definitely doable, but it's also worth pointing out This is the single costliest treaty we've ever done. If you take the second costliest, we tried to look through all the different treaties. There's some different estimates of these. The Versailles Treaty probably cost about $250 billion once, if you added up all the costs that everybody, and of course inflation adjusted till today. So we're talking about something that is about twice to 4 times more costly than the Versailles Treaty, but every year. That's a huge cost. We would at least expect this to do a lot of good, but unfortunately it doesn't. We know that it'll deliver very, very little. To give you a sense, we estimate it'll cut the 7.5 gigatons of CO2 by 2030. It'll cost $1 to $2 trillion per ton of CO2 reduced will be at least $123 to $246. The social benefit, and this is the high end of the Obama version, is about $50. I have strong reservations about that, but let's just go with that for now. That means for every dollar the world spend, we avoid about 20 to 40 cents of climate damage. That's a bad deal. That's a bad way to help the world. And the truth, of course, is we're probably going to end up spending a lot more costs. And so that's why I want to spend the last bit and talk about, so how do we think about doing this better? As you mentioned, Teresa, there are clear costs to climate. There's also clear cost to making climate policies. The point here is to say, if we do too little, we end up making the world worse off. But if we do too much, we also end up making the world worse off. How do we find that middle ground? How do we weigh the costs and benefits? And here, of course, I'm laying out to the new guy who got the Nobel Prize in economics, Bill Nordhaus, the first climate economist to ever get the Nobel. And he has spent his entire career answering this question. So there's no doubt that this is one of the most prestigious economists in the world. This is very, very well received, and it's very, very well known. Yet almost nobody treats this as anything but, we're not actually going to talk about it. Let me show you this. So what you see out of the x-axis is the temperature rise by the end of the century. Now, remember, a lot of these will actually include rises for a long time after that. I'm actually looking at a model. This is Nordhaus model that looks at the next 400 years out till 2510. So the next 4 centuries, what will happen? Well, if we don't do anything, in his model, we find a temperature rise of 4.1. That's a little more than what I showed you at 3.8 degrees, but roughly the same. 4.1 degrees, if we don't do anything more than what we've done today, the total damage cost over the next 4 centuries will be about $140 trillion. That's a lot of money. That's a lot of money. So clearly, we should be concerned about, is there a way that we could reduce that? Well, yes. If we look across the different targets here, these are some of the different, and of course, it's a straight line. I've just only modeled some of them with his model. If we reduce the temperature by the end of the century, the costs of climate will decline. So if we get close to 2 degrees, as you can tell, we could actually have a cost of only $40 trillion. And of course, you can sort of imagine if we reduced it all the way down to 0, we could almost reduce the cost down to 0. There's a reason why it's not going there. Let me just show you this. So clearly, this is the argument that you almost always hear. Hey, why should we have a world where we have to pay $140 trillion? Let's get down to the world where we only have to pay $20 trillion. That's absolutely right, except you have to remember that there's also a policy cost. Now, the policy cost for doing nothing is very, very small, as you can see. The policy cost is about $0.3 trillion. But it increases. This is the policy damage cost. This is the cost that we have to pay to use worse energy than the energy that we would otherwise have had. This is, again, all from his model. So what you see here is, if you get up to 3.5 degrees, you will have a policy cost of about $20 trillion. If you get all the way to 2 target, you almost have a policy cost of $180 trillion. Now, if you're an economist, you'll probably think, oh, we should go where the 2 lines cross, but we have to pay both of these lines. So we actually have to add them up. Here's the added version, right? So add the 4 the $140 trillion and the almost nothing, and then you get $140 trillion. This is the total cost from climate damage and from climate policy damage. This is the graph that we need to optimize. As you can tell, the best outcome is at 3.5 degrees. At 3.5 degrees, we've actually reduced the climate damage significantly, but we haven't increased the policy damage significantly. So that's where instead of having a cost of $140 trillion, we only have a total cost of $110 trillion. We've made the world $30 trillion better off. That's great. This is what Nordhaus tells the world. This is what we should be doing. We should be going for the 3.5 degrees. Remember, that's not very much, but it will actually make the world a better place. Notice, however, what we should not do is to get close to 2 degrees, because then the cost dramatically escalates out of control. You might ask, why don't I have 2 degrees? Why don't I have 1.5 degrees? The simple answer is because we can't do it. When people are arguing, oh, we're going to do 1.5 degrees, they're not lying, but they're certainly fibbing. They're telling you something that basically relies on a technology that we have no idea how to make work, namely that we can have enormous negative emissions by the end of the century, that we can basically suck up a lot of the CO2 that we're emitting now. We have no idea how we're going to do it, and it's the only way that we can live up to the 1.5 and even the 2 degree target. Nordhaus estimates that 2.3 degrees is probably the lowest we can go, and notice that will be a phenomenally costly affair. I want you to emphasize 2 things. One is, let's just take a look at the total cost here. So this is what we want to maximize, but remember, compared to the total welfare for the world, which is what you see up there, which is about $4,500 trillion over the next 4 centuries, the cost of climate, both of climate policy and climate damages, is fairly small. We're talking about 2 to 3 degrees, unless we're getting to a very, very high end, to the very costly end. So if we do it really, really well, we can do about 0.7% better off. That's good. Remember, that's what we spend on global development aid every year. So it's not a trivial amount. But it's not what matters when you talk about most issues, as you can see up there in total welfare. This is one of the reasons why I try to emphasize global warming is a problem, but it's just, no matter which way you slice it, the biggest issue of the world. The biggest issue, of course, is to make sure that that total welfare, which is what is going to make most people's lives worthwhile running for the next 4 centuries, high. The other thing I want you to look at, let me just get back to this. And let me also just scale it back a little bit to make space for something. The problem here again is that we're estimating this using the same argument that all economists do, namely that everybody is going to do all the smart things. So the policy cost is estimated by having everyone in the world having a coordinated single CO2 tax across the entire century. So we're going to agree with Donald Trump, with China, with India, with Africa, with Latin America, and all the way through the century of taxing something that's incredibly hard to do, as Macron found out last year, right? The fundamental point is that that is excruciatingly unlikely to happen. If you allow me to just replace this with the more realistic assumption that this at least will be twice as expensive, which we know is what happened in a fairly well-coordinated EU, this is what happens instead. The costs go up, and perhaps not surprisingly, the total costs go up again. And so what you have here is that the best outcome is still less. Yes, it's at 3.75. But notice it's not very much. If I can just pull out the total cost, this is what we want to minimize. We should not do just where we are now. We should do a little bit less. We should cut a little bit. But the real challenge here is to make sure we don't promise too much, because there's a small opportunity for improving the world, and there's a huge opportunity for making the world worse off if we end up promising a lot, if we end up cutting carbon emissions a lot. because the benefit that we confer on the world are going to be much less than the costs we're going to confer. And again, if I can just show you this compared to the total net welfare of the world, this is total consumption over the next 4 centuries, what is obvious is it doesn't really matter whether we end up in 4.1 or 3.75 or wherever. What matters is that we don't try to get close to 2 degrees, because then we really start screwing up the world. Again, my point here is not to say that global warming is not real. It is to say that it's a very hard problem to solve, and it's a very expensive problem to solve. And unless we do it very precisely, we're likely actually to end up losing more. So let me just wind up with, so what policies do work? Well, a good recession always works. Had the 2008 crisis been longer and been more expensive, we would actually have achieved Kyoto as a world. Technology, for instance, the EU invests a lot in wind and solar, but the EU pays about $40 billion to cut much less CO2. One of the most successful ways of cutting carbon emissions has been the US shale gas adventure. They basically made gas a lot cheaper through fracking, and that means that gas has replaced a lot of coal in the US, about 10 percentage points. It's the biggest single reduction we've seen over the last decade. This was not motivated by trying to do something about global warming. This is purely profit, but the US actually sunk about $10 billion into research and development to make it happen. And the net effect was that this is probably the single biggest reduction in CO2 emissions. And by the way, the US makes about $300 billion a year. It's a lot easier to convince people to say, let's do something that actually makes you a lot of money and cuts a lot of CO2, rather than cost you money and cuts less CO2. The long-term solution, as we found, is to invest in green R&D. I work with lots of economists. As you also, Alejo, you pointed out, we work with more than 300 of the world's top economists, 7 Nobel laureates, and many others on where can you spend resources and do the very most good. What they told us when we looked at climate was invest in green energy R&D. They suggest that we should spend 0.2% of GDP. That's a lot more than what we're doing right now. It's about 6 times as much as what the world is doing now. Actually, in the sidelines of Paris, this was also what was promised. Bill Gates, together with Obama and many, many others from many of the OECD countries, promised to do this, but we've actually not seen that happen. This is what we should be doing. Unlike the present-day policy, this will actually fix global warming in the long run, and it'll be much more effective. We estimate the current EU policy gives you about 3 cents back on the climate dollar, whereas green energy will give you $11, so about 500 times more good back. So my point here is simply to say, what you've heard about global warming is often only very one-sided, in the sense that you hear about the catastrophes, but you don't hear about the totality of it. You don't hear about what are the actual impacts across long run, and you don't hear about the cost and the benefits of both doing something and not doing something. I've tried to show you this. All of what I've shown you is fairly unremarkable. This is something that almost everyone in the literature knows about. Yet it's not something we talk about, and I think we should. There's one last thing I want to leave you with, because this is what I really do, and as Alejo also pointed out, what I work on is mostly not on global warming, but on all the smart things that we should be focusing on. I just want to give you a very, very quick version. There's lots of other problems in the world. I often ask audiences, what's the world's deadliest environmental problem? And almost everyone gets it wrong. I'm just going to show you. If you look at the biggest killer in the world of environment is indoor air pollution. The second biggest is outdoor air pollution, then lead, water and sanitation, ozone, then global warming. This is a World Health Organization estimate, and then radon. If you add on, but it's going to get worse in 2050, this is what the World Health Organization estimates. So it is a problem, by no means the biggest problem. But of course, remember, what's the biggest problem in the world? It's poverty. Poverty kills probably about a third. And again, these are very rough numbers because you can't assign them. There's some double counting involved in this. But poverty probably kills about a third of all deaths in the world that we see. And that's also why the UN asked about 10 million people, what do you want us to prioritize? These were their answers. Again, you can't find it anymore. You can find it on the data link that I'm showing down there, but the UN doesn't actually show it because it gave the wrong answer. Education, health, jobs, not surprising, are the top outcomes. Then corruption, nutrition, no violence, clean water and sanitation, support for people who can't work, better infrastructure, equality, reliable energy, no discrimination, political freedom, protect forest, rivers and oceans, phone and internet. And then at the very bottom came action on climate change. If you're poor, your first priority is simply not to cut temperatures a little bit in 100 years. It is to make sure that your kids don't die, that they get a good education, they get nutrition, so that they can actually go on and do better than their parents. And that's why I work with some of the world's top economists. We did this for the SDGs, and I have a folder here for you where we tried to look at, for all the different SDGs, just send this down that way and this way. I have more, but let me know if you need more. I'm just going to show you very briefly what were the costs and benefits for each one of the different things that you can do. For climate and energy, double renewable energy, unfortunately, it doesn't do very much good. It costs about $500 billion, delivers $400 billion of benefits. That's why every dollar spent will only do 80 cents of climate social benefits. Climate adaptation is a pretty good idea. Efficiency, electricity to everyone, more energy research. That was the one I showed you with 11. Modern cooking fuels as a way to avoid indoor air pollution. Phase out fossil fuel subsidies, again, a great idea. But there's many, many other. Mobile broadband in developing countries can probably deliver about $17 back on the dollar. Biodiversity, half coral reef loss will deliver $24 back on the dollar. Reduce child malnutrition, $45 back on the dollar. There's lots of health intervention, half malaria infections, cut tuberculosis death by 95%, or expanded immunization where every dollar will do $60 of social good. Universal access to contraception will probably do $120 worth of good. Free trade, we estimate, will do about $2,000 of social good per dollar spent. Again, and this is just a small subset, you will actually be able to see the full list there of all the things we did. This we did with 50 teams of some of the world's top economists. The main point here is simply to say, we should talk about global warming because we're spending a lot of money on it, but we should remember, if we actually want to do good for the world, there's a lot of other things we need to focus on. I'm sorry, I think I've overstayed my welcome, but thank you very much for listening, and I look forward to your questions.